Welcome to Coding with Tom. Today we're going to do first some cleanup so that our view models in the scenes don't call the services directly. Instead, we're going to do use cases. We're going to also change our implementation so that we're not just storing the categories that we fetch from the web and memory. We're also going to be caching it on disk. Then we're going to be supporting deep link so that we can open the detail of the restaurant when a certain URL is typed with an idea for restaurant, and we're going to present this restaurant on screen. We will begin by doing a little bit of cleanup. Right now our view models in the scenes are calling directly the services. We will make it so that the scenes, the view models, only call use cases that handle different services. This will make it easier for reusability and maintainability. Let's start by cleaning the restaurant service and creating other services that we will be using for this exercise. Our restaurant API will be doing the network calls that the restaurant service was going to be doing. The only difference is now we are in a completion handler, so the use case that's calling the service will do something with the data. And our restaurant service is just the source of truth. It's the one that's keeping the categories in memory and updating the publisher. Now, besides these two services, we are now going to be caching in the device. So we're going to be stored each time we're going to be calling the service. We're going to be storing the restaurant categories, the restaurants and the ratings, all of them on the device. That way, next time we open the app and we don't have a network, or we're opening from a deep link and we haven't yet updated our categories from the network, we'll have some information to go with. This is our cache. We we create a categories file by asking the file manager for the URL of the documents directory in the user domain mask, and then we append the name of the file, which is going to be categories. In our getter, what we're going to do is from our data, we read the files of the URL, we read the contents of the URL. Then, because our class is decodable, we ask the JSON decoder to decode the data into the restaurant categories, and if all of this is successful, then we return the categories. For the setter, as you saw, I transformed our models to codable. This means that they conform both to the codable and decodable protocol. So because it is codable, we can get these classes and encode them to data, and then data can write to a file URL, which is what we have here. Right now the project is not compiling because our scenes can no longer use the methods in the restaurant service. So let's create use cases so they can use the restaurant service and API methods. Okay, now let's go to our view models and update everything. And now we have our scenes using only use cases. I'm going to create one more use case to update the source of truth with the categories that we have stored on the device. And now we're gonna do this updating of the source of truth with the cache categories when we start the app. In SwiftUI for that, we don't have a scene or app delegate. We have the app. So for this, our app is also going to have a view model. So as soon as it is initialized, our view model will execute the use case. Okay, so now we're ready to test our caching. Let's run the app once. Everything is working right now. Now let's kill the app. Let's stop this. And let's try running without the service to see if we are actually storing everything. You can see here, I think this is, yeah, this is the error from the connection. So as you see, it couldn't connect to the server, but we still have our data cached. Now let's keep this and let's start with our deep links. So for our deep link, we're going to be using this command line, which is useful for opening deep links in a simulator. And notice the URL that we're going to pass. It's going to have a different scheme. It's not going to be HTTPS or HTTP. And we're going to be passing the domain of our app. And in the URL, we're going to specify we're going to go to a restaurant. And in the query parameters, we're going to send the restaurant ID. Now, in order to support our app opening different schemes, we need to support this CWT new scheme, and for that we need to go to our info plist. So here in the URL types we need to add it. And for our identifier we're going to use the bundle identifier. And now we're ready to, with this we can now open the app. Right now if I run this, this will just open the app. Here, let's run the command. And you'll see that my simulator now displayed if I wanted to open RestApp, and it opens. Now we need to make it so that when we open this, it reads this restaurant ID and takes us to the restaurant detail. In order to support deep link in SwiftUI, we need to be able to pass what's being changed down through the Swift hierarchy. So in the RestApp, it's where we are going to catch the open URL for the deep link, but our views downstream need to be notified of that change. And we're going to use the view model to store that state that's changing. So we need to make some changes here. Our restaurant view model needs to be an observable object. And the restaurant that's gonna be choose is gonna be publish. So this is what the other views are going to be listening to. And now let's create a method here to listen to the URL. So we're gonna be first checking that the URL comes from the scheme that we created, the last path, and that the last path component is the restaurant detail. Then we extract the restaurant ID from the query item. And with the restaurant ID, we already have a use case that fetches a restaurant for a given ID. And then we set it in our restaurant variable that's gonna be used by the views. Now all we need to do is go to our categories view and actually set that. Now, we're gonna now be handling selection in the list. I'm gonna show you two ways to react to the div link, by the way, and you're gonna see why. But the first one will be, we're gonna handle the selection through the list. But for that, our row items need to conform to hashup, not just identifiable. Now, in our categories view, let's add the environment object. This is the one that we're gonna be listening to. And let's also add the selection. So our selection is going to be a row item. So here the only thing we're doing is adding a tag to the navigation link and to the row. If we run like this, nothing has changed. Now we need to add another view modifier, which is on receive. So we're going to be creating a row item with a restaurant view model, which is the restaurant that changed in the add model, and it will have no children. We're not going to build the entire hierarchy again. Let's try doing this, nothing has changed. Now you'll see what we're going to do as the second iteration. And let's see, X0. Now you'll notice that nothing happened, even though we have already our publisher. And let's. Oh yes, I never actually added the modifier. And now we are passing the URL to our model for it to handle. Let's try this, and you see that nothing happens. Now let's open the list, and we are checking. So I don't know if that's a bug in SwiftUI or it was an intended behavior by Apple, but if the list is collapsed, the row that has the corresponding tag, which is M1, only travels to this view when it's open, when it's visible. And from what I have read, had it been a row that's off screen, only when I scroll, it will navigate to that. So instead of having this traveling to the row item, we're going to be presenting modally the restaurant. So again, everything here works. Now let's try opening up the link. Okay, and we got it. Now I didn't add the navigation view with a logic to display this because in iOS 13 we are presenting in like a card, so we can swipe down and it stopped presenting. Let's try opening another one. Here we have it. Let's try closing and opening another one. And there we go. We have the thinking presenting modally. And that was all for today. As you could see, moving the functionality to our use cases, it made it very easy to reuse it in different parts of the app. Caching in disk with an already codable model entity is really easy. You just transform it to data, and the data class already has methods to retrieve and to write contents of a file with the URL. So that was pretty easy. Handling things in SwiftUI seems kind of buggy right now, but if you handle it through model presentation like you saw that I did, it brought a pretty stable behavior. Also, using the sheet presentation, it's very easy to rely on the swipe to dismiss behavior. That was all for today. Bye.